Hey everybody, welcome to Algebra 1, Section 5.3, Slope-Intercept Form. By the end of this lesson, you should be able to write a linear equation in the form y equals mx plus b if you're given the slope and the y-intercept, if you're given a point and the slope, from 2 points, from a graph, or from a story problem. You should also be asked, you could also use the equation to find the slope and the y-intercept. Also, use the equation to graph. Sounds like a lot, and it really is, but once you get used to it, it's not that bad. So let's hop right into it. First, slope-intercept form. You may have heard of this before, probably better known as y equals mx plus b. Now, we've been working with x and y quite a bit, but what do m and b stand for? As we talked about in our previous lesson on slope, m stands for slope. Again, I don't know why they call it m, but they just do. The y-intercept is b. So, if you ever see y equals mx plus b or something that looks like that, whatever's in the m is your slope, whatever's in for the b is your y-intercept. So, for instance, if I tell you that the slope is 3 and the y-intercept is -2, what equation could you make? Well, just plug those numbers in. The 3 goes in for m, the -2 goes in for b, and you get y equals 3x minus 2. Fairly simple. Let's try it again. If the slope is -1/2 and the y-intercept is 8, plug them in, and you get y equals -1/2 x plus 8. Okay, so if they give you the slope and the y-intercept, it's just as easy as plugging it in and leave the letters x and y in there. But that's all you have to do. Now, it's not always going to be that easy, but sometimes it is. So what I want you to do now is reverse of that. If I give you the equation, can you tell me the slope and the y-intercept? So in the equation y equals 2/3 x minus 5, the slope is going to be 2/3 because it's what's right in front of the x. The y-intercept is going to be -5. Let's do another one. If I give you y equals -7x, you'd probably figure out that the slope is -7 because it's right in front of the x. But what about the y-intercept? There's nothing there. Well, how do we express nothing in math? That's right, 0. So in this case, the y-intercept is -7, and the slope is -7, and the y-intercept is 0. One more. What if I have y equals x plus 6? So the slope is always right in front of the x, but in this case, there's nothing right in front of the x. Now, the answer is not 0. If you don't see a number in front of the x, what do you know the coefficient is? It's going to be 1. Because just by having an x there, you've got a x there. You have one x there. So 1x and x mean the same thing. So we know our slope is 1. And then our y-intercept is 6. So how does that help us? What's the point of knowing what's the slope and the y-intercept? Well, if we were to graph this, that tells us exactly where to put the line. So what we could do is we could start at the y-intercept, which is where it crosses the y-axis. So I'm going to go to the y-axis and go up 6 spots and put a dot. If my slope is 1, that means from that dot that I just put, I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, and I've just got a whole bunch of dots. And then I just connect those dots, and boom, I've got my graph. So let's go ahead and do a few examples of that where we're taking the equation and making the graph. Okay, so here we go. We've got a graph grid right here. We also have a bunch of equations of lines. One of the goals of today is to be able to take an equation and write the graph from it. So the first one, y equals 4x minus 3. I'm going to take the fact that I know the slope and I know the y-intercept, and I'm going to graph this very, very easily, much easier than what we did in chapter 4. So if my y-intercept is -3, then I go to -3 on the y-axis, and I put a dot. That's all you need the y-intercept for, is just tell you where to start. And then to get more dots, I use my slope. The slope will tell me how to get from one dot to the next dot to the next dot. So if my slope in this case is 4, remember a slope is a fraction, rise over run. So 4 as a fraction is 4 over 1. So that means from that point that I just created, I'm going to go up 4 spots and over 1, and there's a dot. And then I can do that again, go up 4 more and over 1. And that gives me a pretty clear idea of where I'm going to put my line. So just connect the dots. Now in theory, lines go forever, so I'm going to put little arrows on the end. And there we go. There's my line. Let's try another example. So y equals 2/3 x plus 1. So always start with your y-intercept. Since my y-intercept is 1, I go up 1 and put a dot. And if my slope is 2/3, that means I go up 2 and over 3. 2, 3. I could go up 2 and over 3 again. I kind of run out of room, but I've got a pretty good idea where that dot goes. So I know where my line goes this way. Oops. But what about the other way? If I don't know where my line goes, I can use the opposites. Instead of going up 2 and forward 3, I can go down 2 and backwards 3. Down 2 and backwards 3. And that gives me a pretty good idea where my line goes in the other direction. Now, what do I want to avoid? Why do I put all those dots in there? Because I see some kids, when they do this, they're like, okay, well, I get one dot here and another dot there, and there's my line. And they get real sloppy with it. I guess you could get by with only using 2 points if you used a ruler or some sort of straight edge and then lined those 2 points up and did that. But if you want to be more accurate, which I would encourage you to do, the more dots you put, the better. So let's try another one. Negative 3x minus 4. So I'm going to start at negative 4. And my slope is negative 3. So that means I go down 3 and forward 1. Okay, again, because it's negative, I should know which direction my line's going to go. But if I go down 3 spots, I run off the grid. So instead of going down 3 and over 1, I'm going to go up 3 and backwards 1. Up 3 and backwards 1. Up 3 and backwards 1. All right, and that confirms just the way that the line is leaning. That confirms that it's negative. Because if you remember, a positive slope goes this way, a negative slope goes that way. Zero slope is like this, undefined is like that. So that's a good way to double check yourself, because a lot of times people will get the right count, but they'll be going in the wrong direction. All right, let's do one last one. So y equals 5/4 x plus 3. So I go up 3. And I should go up 5 and over 4. But if I do that, I run off the grid, so I will go down 5 and backwards 4. And there's my line. Now let's see if we can reverse that logic of what we just did. What if instead of me giving you an equation and you making the graph, what if I give you the graph? Can you make the equation? It's still the same thing. Anytime you want to make the equation, you need two things. You need your slope and your y-intercept. So can we look at the graph and figure out what's the slope and what's the y-intercept? So if I look at this slope, it looks like they've already got dots on there for me. That makes it a piece of cake. We already learned in a previous lesson how to find the slope from a graph. So just by looking at it, I can tell right now the slope is negative. So if I go down 2 and over 1, my slope is negative 2 over 1, which is just negative 2. So that's one of the things that I need to make my equation. The other thing that I need is the y-intercept. So all I have to do is take a look at the graph. Where does it cross the y-axis? Well, it does that at 5. So now that I know my slope, I know my y-intercept, I can go ahead and write the equation. Y equals negative 2x plus 5. Not too bad. Let's take a look at this one. Okay, so where does that hit? It doesn't have the 2 dots already on there, so I have to find the 2 dots. So it looks like it hits there, and not quite there. Looks like it doesn't hit the grid again until right about there. So again, I can tell that my slope is going to be negative. So it looks like I go down 4 spots and forward 1, 2, 3, 4, 5. So it looks like my slope is negative 4/5. And then my b value, where does it cross the y-axis? Well, it crosses it right there at 4. So that makes my equation y equals negative 4/5 x plus 4. Final answer. Let's do one last one. Okay, for my slope, I can tell that my slope is going to be positive. So if I go 1, 2, 3, 4, and then over 1, 2, 3, 4, 5, 6, my slope is 4/3. Now I don't like 4/3 or 4/6. I don't like 4/6 as my slope because it can reduce to 2/3. So that's my slope, 2/3. Where does it cross the y-axis? Looks like at negative 4. Now when I do that, I don't need to get the coordinate 0, negative 4. The x-coordinate will always be 0 on your y-intercept. So just take a look at where it hits the y-axis, negative 4. So then my equation is y equals 2/3 x minus 4. Final answer. Okay? So, what if, instead of giving you a graph, what if I just give you information about the line? Could you figure out the equation of it based off of this information? So it says, find the equation of a line with the following information. The slope is 3 and passes through the point 4, 1. So if you recall, you only need 2 things to find the equation. You need the slope and the y-intercept. Well, they give us the slope, so that's half the information that we need. But they don't give us the y-intercept. Instead of the y-intercept, they give us some random point that the line goes through. So I have to figure out what the b value is. Now, in order to do that, I need some equation that has b in it. And the only equation that I know of is y equals mx plus b. So what I'm going to do is I'm going to plug in numbers for everything except the b value. So I know my m value is 3. What about x and y? Well, that's where that coordinate comes in, because every coordinate has an x and a y value. So I know that that 4 is going to go in for x. I know the 1 is going to go in for y. And that plus b is going to stay plus b. If you're plugging numbers in and you don't have plus b, you're doing something wrong. Something that some people like to do is they like to take that 1 and plug it in there. They say, oh, well, that's the y-intercept, and our y-intercept is 1. That's not our y-intercept. That's our y-coordinate, but that's not our y-intercept. So that 1, that y-coordinate, has to go in for y, not for b. So now all we have to do is work this out. Obviously, 3 times 4 is 12. Subtract the 12. And there we go. I now have exactly what I need to write my equation. I know my slope, and I know my y-intercept. Now, some people will get excited. They're like, all right, I found b. And they get so excited that they just stop there. Don't stop here. Okay? The instructions say write the equation. Just because you found all the stuff that you need doesn't mean you're done. Now that we know the slope and the y-intercept, let's plug those values into y equals mx plus b. So 3 goes in for m. My b value is negative 11, so minus 11. And that's my final answer. Y equals 3x minus 11. Now, I know that was a lot, so let's go ahead and do another one. Now, this is going to work the same way. We're going to take all the information that we have, plug it into y equals mx plus b. So, my slope is my m value. My x value is 6, and my y value is negative 2. So 6 goes in for x, plus b. Make sure that plus b is in there. And negative 2 goes in for y. Half of 6 is 3. Oh, that's an ugly 2. Subtract 3 from both sides and you get negative 5. So there we go. We now know the y-intercept. So I'm going to take the slope being 1/2 and the y-intercept being negative 5. And there's my equation. I would highly recommend getting very familiar with this process. You're going to run into it a lot, not only in this class, but also in geometry. And who knows, you might be walking down the street someday and someone puts a gun to your head and says, hey, can you write the equation of a line that has a slope of negative 2 and goes through the point 5, negative 3? And if you're ever in that situation, you'll be prepared. All right, moving on. What if instead of giving you the slope and a point, what if they give you 2 points? Because if you got 2 points, you can draw a line. So 2 points should be enough information to be able to write the equation of that line. So if they give you 2 points, you no longer have your slope, you no longer have your y-intercept. You got to figure out both of those things. So let's get to it. If we got 2 points, what can we do with that? Well, in our last lesson, we learned how to find the slope. So let's get a different color in here. Let's use the y2 minus y1 over x2 minus x1. So y2 minus y1 and x2 minus x1. Now, can anyone spot the mistake that I've made already? I'll give you a second. All right, here it is. When I did the y2 minus y1, I did 1 minus 7. But it should be 1 minus negative 7. Okay? You got to watch out for those signs. They'll get you every time. So 1 minus negative 7 is the same as 1 plus 7. And then 5 minus 3 is 2. 8 over 2 is obviously 4. So there we go. I've got my slope. So now we're in the situation that we were just in with these types of questions, where we have our slope and we have a point. The only difference is we now have 2 points. So we get to choose which numbers we want to plug in. So I'm going to take the y equals mx plus b. Tell you what, let me get a different color just to differentiate the steps. So let's take y equals mx plus b. Let's plug in the 4 for m. And then it doesn't matter which point you choose. You can choose the 3, negative 7, or you can choose the 5, 1. It doesn't matter. But what you can't do is you can't choose one number from one point and then another number from the other point. That doesn't work. Me personally, I'm going to choose the 5, 1 just because they're both positive. So the 5 goes in for x. The 1 goes in for y. And make sure that plus b is still in there. So 4 times 5 is 20. Subtract the 20 from both sides. And there's our b value, negative 19. So now I just take the slope that I figured out. Oh, that's an ugly x. Okay, so the slope is 4. I just figured out the y-intercept is negative 19. So there we go. There's my equation. Now you may be asking yourself, well, what if I had picked the other one? Well, let's see what would have happened if we had picked the other one. The slope is still the same. My x value is 3. And my y value is negative 7. And keep that plus b in there. 4 times 3 is 12. Subtract the 12 from both sides, and you get negative 19. So you see, no matter which way you do it, you still get the exact same answer for your y-intercept. Okay? So that's our final answer right there. Y equals 4x minus 19. Whew. Take a break if you haven't already, because that was a lot. Now, I will tell you, that type of question where you're given 2 coordinates, that's the toughest kind of question you're going to run into in this section. All right? So if you can do those types of equations, you should be fine. So let's move on to the last skill I want you to know. Of course, everyone's favorite, word problems. How can you write an equation based off of a word problem? Well, in any word problem where you're going to use y equals mx plus b, there's always 2 things we're looking for, the slope and the y-intercept. So your slope, your rate of change, is how quickly something is changing. So in this case, we're talking about the money that a taxi charges. So you want to know how much your money is changing over time. So you look for the words per, for each, for every, any of those words that mean multiply. And when you see that, that's going to be a very good indicator that that's your slope. To find your y-intercept, it's always what your starting value is, your initial value. So let's read this problem. A taxi charges a $5 pickup fee and 25 cents per mile. Write an equation to model this. So I know my equation is going to have y and x in it. I just need to know the slope and the y-intercept. So remember, to find the slope, look for per, for each, or for every. So, because it says 25 cents per mile, that's going to be my slope. It's 25 cents. And then the initial value, so in this case, before the taxi even takes you anywhere, just to show up at your doorstep, they charge you $5. So that is your pickup fee. That's your initial value. That's your y-intercept. So there we go. There's my equation. Okay, that's all they asked us to do was to write the equation. There it is. Y equals 0.25x plus 5. Let's do another one. A cell phone company charges $700 for a cell phone and then $79.95 for every month. Model this with an equation. Well, I see right there a key word, every month. That's a pretty good indicator that that's going to be our slope. So $79.95 x. And then what's our initial value? Well, before you can start using the phone every month, you got to pay $700 just to get the phone. So that's our initial value. That's our y-intercept. So there's our equation right there. Y equals $79.95 x plus 700. Now you may ask yourself, okay, so what's the purpose of writing the equation? Well, now we can use that equation to predict things. Like, if I'm going to keep this phone for 10 months, how much is it going to cost me? Well, where do I plug that 10 in? Well, since it says $7.99 every month, that's what x represents, is the number of months. Up here, it was 25 cents per mile. That's what x represents, is the number of miles. So when you find the phrase per, for each, or for every, the number going along with that is your slope. Whatever quantity after that is what x represents. So if I'm going to do this for 10 months, All I have to do is plug in 10. So that'll be 799.5. So what that means is over the course of 10 months, you are going to spend $1,499.50 on your cell phone. And the way some of you guys act, I imagine you would spend a lot more on that just to be able to keep your cell phone. So think about that. Your parents pay so much money for you to be on your cell phone. Probably should say thank you every once in a while. All right? So hopefully this was an okay topic for you. There's a lot jammed in here, so I imagine we'll have lots to talk about when we get to class. So feel free to email me, feel free to ask me in class, but let's make sure that we understand how to use the slope-intercept form. All right? You guys have a good one, and I'll see you real soon.